Hi guys, in this video I'm going to be going through Pythagoras' theorem, which is a special property which holds for all right-angled triangles. And we'll see that this only works for right-angled triangles, and in fact we use this to prove if a triangle is indeed a right-angled triangle. So before we do anything else, let's look at what we mean by a right-angled triangle. So let's just draw a right-angled triangle like so. Alright, so here's our right angle triangle. Clearly the main feature here is the right angle. So we have our three sides, and we have special names for each of these sides. The longer side is what we call the hypotenuse. And that is probably the most important side of a right angle triangle. The hypotenuse, you'll see, is always opposite the right angle as well. So that's how you can always tell it's going to be the longest side. We also do have names for the other two sides called the opposite and the adjacent, but you learn more about that once you get into year 9 and year 10 when you start looking at trigonometry. So for now, we're just going to be looking at the hypotenuse. We often refer to the hypotenuse with the letter C. And then the other two sides, we're going to refer to them as A and B. So here we have our hypotenuse, our right angle triangle with a hypotenuse we label C, and the other two sides A and B. It doesn't matter which side you call A and which one you call B, as long as the hypotenuse is C. Typically we say that A is the shortest side, B is the middle, and then C is the longest. So the actual Pythagoras theorem itself says that C squared equals A squared plus B squared. So this is the most important thing we're going to be focusing on today. What this tells us is if we got the length of the hypotenuse and we squared it, that would equal to the sum of the squares of the other two sides. We'll show this in a few examples now. So say for example I had a right angle triangle that looked something like this. So we had this, say this was 3, this was 4, and this was 5. And let's actually pretend that I didn't know that this was a right angle triangle, and I wanted to show if it was a right angle triangle. First of all, we need to determine which one is our hypotenuse. We can see quite clearly that 5 is the longest side, so that is going to be our hypotenuse, which we'll label C, and that means the other lengths we're going to call A and B. So again, as I've said, it doesn't matter which one is A and B, as long as C is the longest side, which is the hypotenuse. Now, if we want to check to see if this is a right angled triangle, we need to check both sides of Pythagoras' theorem to see if it works. So first of all, if I did 3 squared plus 4 squared, well, we know that 3 squared is 9, 4 squared is 16, so 9 plus 16 equals 25. And then if I did the hypotenuse squared now, which is 5 squared, I see that this is also 25. So because we see that both of these are equal to 25, that means therefore it is a right-angled triangle. Because it worked, because they both ended up being 25. We actually have a special name for a pair of 3 letters or a group of 3 letters where it works. If we can say that the group 3, 4, 5 is a Pythagorean triad. So if we have 3 numbers that works in Pythagoras' theorem, we call it a Pythagorean triad. If we tried another one, maybe we could make it look a bit different. So say I had, maybe this was 10, maybe this was 3, and this was 7, and I wanted to check if this was a right angle triangle. So first things first, we need to check to see if which sides we have. So that's going to be the hypotenuse. Here's our A, here's our B. So from that, if I did 3 squared plus 7 squared, well, we know 3 squared is 9, 7 squared is 49, so that equals 58. And if I did 10 squared, well, that equals 100. And we see that these two don't equal the same. So therefore, it is not a right angle triangle. And that means the numbers 3, 7, 10 do not form a Pythagorean triad. So what we're looking at is squaring the numbers and seeing what they add up to, and then squaring the other two and see what that is. Don't just take a shortcut and say, oh, well, 3 plus 7 equals 10, so that means it's going to work. We see here that doesn't work. So now we've seen what Pythagoras' theorem is and how we can use it to show if something is a right angle triangle. But what we can also do now is use Pythagoras' theorem to find any missing side lengths. So say, for example, let's draw up another one like this. Say that this was 6, this was 8, and this was x. And I want to find what the value of x is. So I know it's a right angle triangle because it's given me this. So because it's told me it's a right angle triangle, that will help me. That tells me that I can use Pythagoras' theorem for this. Again, let's start off by first of all looking at the sides. So this is our C, that's the hypotenuse. And then we have A and B. Again, it doesn't matter which one's A, which one's B, as long as the hypotenuse is C. So now we can put this into Pythagoras' theorem. We'd say that x squared equals 6 squared plus 8 squared. So we're saying that the hypotenuse squared is equal to the sum of the other two sides squared. When we put this into our calculator, we'll get x squared equals, 36 and 64. So 36 plus 64. We'll get x squared equals 100. So what we need to do now is find the value of x, because quite clearly this length is not 100 units long. If that was 6, that was 8. That would be far too big to say that was 100. However, what we have here is x squared. We don't want what x squared is, we want what x is. So the opposite of squaring a number is square rooting the number. So you can say x equals the square root of 100, which obviously we know x is 10. So that means this side length, the one that we're trying to find, is 10. So again, we can state that 6, 8, 10 is a triad, is a Pythagorean triad. Not that you need to write that every single time, but it's just interesting to note that that's another one of these numbers that fit Pythagoras' theorem. We'll just do 2 more examples. The first one will be a different type of question, and let's just draw it oriented a bit different. So again, let's say that was a right angle. Maybe I'm told that this is, let's say, 20. This is 16, and I'm trying to find what x is here. Now we'll notice that this time we actually know what the hypotenuse is. And I know what A is, and I'm trying to find what the other side is. So this time, if we were to write this into our Pythagoras' theorem, we'd be writing 20 squared equals x squared plus 16 squared. The thing that we're trying to find is on this side with the short sides together rather than the long sides. So from this, we can do 20 squared, which equals 400. We can say x squared, and then we have 16 squared, which equals 256. And then to solve this equation now, of course, I'm going to subtract that 256 to the other side. So I have 144 equals x squared. And then lastly, the final step with these Pythagoras theorems questions is we're going to say that x equals the square root of 144, which obviously equals 12. So that means this side length here is 12. So one last question, and maybe do something like this. Let's make this 17. Let's make this 8. And let's make this x. So again, you need to ask yourself, am I finding the hypotenuse or am I finding one of the shortest sides? Here I'm trying to find one of the shortest sides, which kind of leads my thinking. So just do that. So here's my C, here's my A, here's my B. Again, it doesn't matter which one you call A and B. So we're going to have 17 squared equals x squared minus 8 squared. Now if I do 17 squared, that gives me 289. X squared minus 64. Oh, sorry, that's a plus. And then so I'll do 289 minus 64, which gives me 225 equals x squared. And then when we square root this number, that equals 15. I'll be honest, that was a bit of a fluke. I was trying to get a question where it gave me a decimal answer. But you can imagine if sometimes the square root, the answer that you get will give you some kind of decimal answer in which you will need to round to 2 decimal places or 3 decimal places. So for example, so in this exercise, first of all, you need to introduce Pythagoras Theorem, where we look at this determinant of the following of Pythagorean triads. So you'll be putting into Pythagoras Theorem and seeing if it works. Here we're just checking to see if the a squared plus b squared equals c squared works, and then write down Pythagoras Theorem for these. And then for these questions, you'll need to look like what we did in those examples, find the missing values. Here in question 5, we'll see that we will need to answer to 2 decimal places. As you start working through that exercise, you'll see what it means. And then a few worded problems of this kind of stuff. And then using Pythagoras Theorem to find the length of a short side, where similarly, if we're looking at this, here I'm trying to find one of the short sides rather than the long side, but it works the same way. And a few worded problems. Anyway, solutions are there as well. The expectation is that you guys will work on this over this lesson and maybe the lesson on Friday as well. If you have any questions, feel free to email me. Thanks for watching the video. Hope it helps. Thanks, bye.